June 18, 1940. Lockheed Aircraft Corporation, Burbank, California. 34-year-old Kelly Johnson stared at the Army Air Corps specification lying on his desk. His engineering team waited for his response. Circular proposal. X-608 demanded the impossible. Reach 20,000 feet in 6 minutes. Top speed of at least 30-60 miles per hour. Range of 1,000 miles. Heavy armament. Johnson picked up his pencil, ran the calculations again, and came to the same conclusion. Impossible, he said quietly. No single engine available can meet these requirements. His boss, Hall Hibbard, asked the obvious question. Then what do we do? Johnson looked at the specification one more time, then drew 2 circles on his paper instead of 1. We use 2 engines. Every aviation expert would call his solution ridiculous. Twin-engine fighters were slow, clumsy death traps in combat. But Kelly Johnson would build it anyway. Germans would call it der Gabelschwanz, Teufel, the fork-tailed devil. 10,037 would be built. The 800 German aircraft would fall to its guns. And Kelly Johnson would prove that, sometimes, the impossible solution is the only one that works. To understand why Johnson's twin-engine solution was considered insane, you need to understand what the Army Air Corps wanted, and why nobody thought it was achievable. February 1937. The Army issued Circular Proposal X-608 calling for a new interceptor with unprecedented performance. The requirements were brutal: climb to 20,000 feet in 6 minutes. Maximum speed of 360 mph at altitude. Service ceiling of 20,000 feet minimum. Endurance of 1 hour at full throttle. Heavy armament, no specific caliber specified, but maximum firepower. The best existing American fighter, the Curtiss P-36 Hawk, could reach about 300 mph and climb to 20,000 feet in roughly 11 minutes. The Army was asking for a 20% speed increase and nearly twice the climb rate. No existing engine could deliver that performance. The most powerful engines available in 1937, Allison V-31710, 1,108 horsepower. Pratt & Whitney R-183030, 2,000 horsepower, Wright R. or 1820, 950 horsepower. To meet the Army's requirements, you'd need roughly 2,000 horsepower. That engine didn't exist. Most manufacturers declined to even submit proposals. Lockheed was a small company, known primarily for civilian transports like the Electra. They'd never built a frontline fighter. They had no experience with high-performance military aircraft. But they had Kelly Johnson. Clarence Leonard Kelly. Johnson was born in 1910 in Michigan, the 7th of 9 children of Swedish immigrants. He earned his aeronautical engineering degree from the University of Michigan, where his thesis on wind tunnel testing caught Lockheed's attention. At 23, he joined Lockheed as a tool designer. Within 2 years, he was solving aerodynamics problems that senior engineers couldn't crack. At 27, he was chief research engineer. And at 29, he was handed the impossible X-608 specification. Johnson's approach to engineering was unique. Start with the problem, ignore convention, and calculate what physics actually requires. So when every other engineer said, "We need a bigger engine," Johnson asked a different question. What if we use 2 smaller engines? The idea wasn't completely original. The Germans had pioneered twin-engine fighters with the Messerschmitt Bf-110. The British were developing the Westland Whirlwind, but both designs mounted engines in traditional nacelles on the wings, creating a conventional twin-engine layout. They were heavy, relatively slow, and proving vulnerable in combat. Johnson's radical idea: build the entire aircraft around 2 engines. Instead of adding engines to wings, make the engines the structure. Mount them in booms that extend back to become the tail structure. Put the pilot in a central nacelle between the booms. His team thought he was crazy. Hall Hibbard, Lockheed's chief engineer, listened to Johnson's proposal and said, "Kelly, twin-engine fighters don't work. The Germans are already proving that with the Bf-110. Johnson replied, "The Bf-110 is a conventional design with engines added. I'm proposing something completely different. We're not adapting a twin-engine bomber into a fighter. We're building a fighter that happens to have two engines. The distinction seemed semantic. It wasn't. The key advantage. By making the engines structural, Johnson eliminated redundant weight. The booms carrying the engines also carried the tail surfaces. No separate fuselage structure needed. It was elegant. It was innovative. And Lockheed submitted the proposal in June 1937. The Army awarded them a contract for one prototype, the XP-38, cost $163,000, about $35 million in 2024 dollars. Deadline: 1 year to first flight. Kelly Johnson was 27 years old and had never designed a fighter aircraft. He was about to create a legend. Building the XP-38 prototype required solving problems nobody had encountered before. Problem 1. Turbochargers. To meet the Army's high-altitude requirements, Johnson needed turbo-superchargers, devices that used exhaust gases to compress intake air, maintaining sea-level engine performance at altitude. But where to put them? Traditional installations mounted turbochargers on the engine itself, but the XP-38's unique layout offered a different solution. Johnson mounted the turbochargers in the extended tail booms, far behind the engines. Exhaust gases traveled through ducting in the booms to spin the turbocharger turbines, and compressed air returned forward to the engines. This solved multiple problems, moved heat away from the cockpit, provided excellent cooling airflow, used boom structure for ducting, allowed easy maintenance access. It was brilliant. It was also untested at this scale. Problem 2. Armament. Conventional fighters mounted guns in the wings, requiring them to converge at a specific distance, typically 205 to 300 yards. Hit something closer or farther, and your bullets spread wide. Johnson's central nacelle design offered something revolutionary. Put the guns in the nose, firing straight ahead on the same axis. No convergence needed, no spread pattern, just a concentrated column of bullets and shells traveling the same path. The XP-38 armament configuration, 137mm automatic cannon, later changed 20mm, 4.50 caliber machine guns, all nose-mounted, all firing forward. Combined firepower unprecedented for an American fighter. At 300 yards, all rounds passed through a circle roughly 6 feet in diameter. German pilots would learn to fear that concentration. Problem 3. Visibility and control. Traditional fighters had tailwheel landing gear. The tail dragged on the ground during taxi, blocking forward visibility. Johnson specified tricycle landing gear, nose wheel, and 2 main gear. The pilot could see forward during taxi and takeoff, a huge safety advantage. This was radical in 1939. Only a handful of aircraft used tricycle gear. The P-38 would help popularize the configuration that's now universal. Problem 4. Torque. Single-engine fighters produced tremendous torque on takeoff. The engine's rotation tried to roll the aircraft. Pilots had to compensate with rudder, making takeoffs tricky and dangerous for novices. Johnson's solution: counter-rotating propellers. The left engine's propeller rotated one direction. The right engine's propeller rotated the opposite direction. Torque forces canceled out. Result: the P-38 flew straight and stable with no torque effect. Easier to fly, safer for novice pilots, more predictable in combat. By late 1938, the prototype was taking shape in Lockheed's Burbank facility. Workers looked at the strange aircraft and shook their heads. 2 engines mounted in booms, twin tail surfaces, tricycle landing gear. It looked like something from a science fiction magazine. Test pilots who saw it asked the same question: "This thing actually flies?" January 27, 1939. California. Lieutenant Ben Kelsey, the Army's chief fighter test pilot, climbed into the XP-38 for its maiden flight. He advanced the throttles. The twinned Allison V-17 Hun engines roared to life, producing a combined 2,300 horsepower, more than any American fighter had ever carried. The unusual aircraft rolled down the runway, lifted smoothly, and climbed away. For the next 34 minutes, Kelsey put the XP-38 through basic flight tests. Speed runs. Climbing tests. Stall characteristics. Control response. He landed, taxied back, and shut down the engines. His report was succinct. It flies better than anything else I've ever flown. One successful flight proved nothing. They wanted performance data. Kelsey suggested a publicity stunt that would also validate performance, a transcontinental speed record attempt. On February 11, 1939, just 2 weeks after first flight, Kelsey took off from California heading for New York's Mitchell Field. The plan: fly coast to coast in under 7 hours, breaking the existing record and proving the XP-38's speed and range capabilities. The flight went perfectly for 2,400 miles. Kelsey crossed the country at an average speed of 420 miles per hour, far faster than any fighter had ever flown that distance. Then, 7 miles from Mitchell Field, with crowds gathered to watch the record-breaking landing, disaster struck. The engines quit. Carburetor icing. A problem Johnson's team hadn't anticipated at low altitude and cold weather. Both engines failed simultaneously. Kelsey had 7 miles to go and no power. He couldn't reach the runway. He aimed for a golf course, put the XP-38 down in a controlled crash landing, and walked away. In April 1939, they ordered 13 pre-production YP-38s for evaluation. And in September 1939, before the YP-38s were even built, the Army ordered 6 730 production P-38s. Kelly Johnson's impossible design had just received the largest fighter order in American history to that date. The P-38 entered service in 1941. The first combat-capable versions, the P-38E and P-38F, reached operational squadrons in late 1941 and early 1942. American pilots had mixed reactions. The P-38 was fast, capable of 400 mph in level flight. It climbed like a rocket. The visibility from the cockpit was excellent. The nose-mounted armament was devastating when it hit, but it was also heavy, complex, and different from anything they'd flown. At nearly 7 tons fully loaded, it required different tactics than conventional fighters. Early P-38 pilots tried to dogfight with it, turning and twisting to get on an enemy's tail like in a Curtiss P-40 or Bell P-39. This didn't work. The P-38 couldn't turn with lighter fighters at low altitude. German intelligence received reports and photos of the strange American twin-engine fighter in late 1942. Their assessment was dismissive. A Luftwaffe intelligence report from November 1942, captured after the war, stated, "The American Lockheed P-38 represents an interesting but flawed approach to fighter design. Twin engines provide redundancy, but add weight and complexity. The aircraft's performance at low to medium altitudes is inferior to the Bf-109 and Vftu-190. Pilots report it is easier to shoot down than single-engine types. Assessment: moderate threat, exploitable in turning combat." When P-38s arrived in North Africa for Operation Torch in November 1942, German pilots saw them as easy targets. Oberleutnant Gustav Rudel, an ace with over 90 victories, engaged P-38s for the first time in December 1942. His combat report was condescending: engaged American twin-engine fighter over Tunisia. Aircraft is fast in straight line but clumsy in turns. Pilot appeared inexperienced. Attempted to engage, but P-38 fled using superior speed. No aerial victory achieved, but opponent demonstrated no significant threat. What Rodel didn't mention, he'd failed to catch the P-38. It had simply accelerated away from his Bf-209 in level flight, something no German fighter should have allowed. Other German pilots weren't as cautious in their assessments. Some laughed at the P-38's appearance. The twin booms, the large size, the ungainly look on the ground. Der Gabelschwanz Teufel started as a mocking nickname. The fork-tailed devil, implying it looked more devilish than it actually was. That perception was about to change. The P-38's transformation from moderate threat to terrifying weapon began when American pilots learned to fly it correctly. Major Thomas Lynch, commanding the 39th Fighter Squadron in the Pacific, wrote the tactical manual that changed everything. Lynch's key insight: stop trying to dogfight. Use the P-38's actual advantages. The P-38's real strengths. First, altitude performance. The twin turbocharged Allison engines maintained full power up to 30,000 feet. German fighters with mechanical superchargers lost significant power above 25,000 feet. At 28,000 feet, a P-38 had 2,000 horsepower available. A Bf-29 had perhaps 1,200 horsepower. The difference was decisive. Second, dive speed. The P-38's heavy weight was an advantage in a dive. It could reach speeds approaching 500 mph in a steep dive, faster than any German fighter could achieve. Third, zoom climb. After a high-speed dive, the P-38 could convert that speed into altitude with a zoom climb that left pursuing fighters helplessly behind. Lynch's tactical doctrine became known as boom and zoom. Maintain altitude advantage, 30,000 feet or higher. Identify targets below dive at maximum speed. Fire a 2-3 second burst, zoom climb back to altitude. The tactic played to every P-38 advantage and avoided every P-38 weakness. German pilots who had laughed at the clumsy twin-engine fighter suddenly found themselves unable to counter it. August 17, 1943. The Schweinfurt-Regensburg raids, the deepest penetration into Germany attempted to that date. P-38s of the 50 Fighter Group provided top cover at 32,000 feet, 7,000 feet above the B-17 bomber stream. When German fighters assembled to attack the bombers at 25,000 feet, the P-38s dove from above. Hauptmann Johannes Steinhoff, leading JG-77, reported, "The American twin-engine fighters attacked from directly above at tremendous speed. By the time we could react and turn to engage, they had already climbed back above us and were positioning for another attack. We could not climb fast enough to catch them. We could not dive fast enough to escape them. It was like fighting ghosts." That day, P-38s were credited with 27 German aircraft destroyed. The German assessment of the P-38 changed dramatically. A Luftwaffe intelligence update from September 1943 stated, "The P-38 Lightning must be considered a major threat when properly employed. Its altitude performance exceeds all German fighters above 25,000 feet. When American pilots use vertical tactics rather than horizontal turning fights, the P-38 is extremely dangerous. Pilots are instructed to avoid engagement at high altitude when possible, but the nickname stuck. Der Gabelschwanz Teufel, the fork-tailed devil. Now the name carried no mockery, only respect and fear. By the end of 1943, P-38s were racking up impressive numbers. Richard Bong, P-38 pilot, Pacific Theater, 28 victories by end of 1943, eventually 40 total. Thomas Lynch, P-38 pilot, Pacific, 20 victories. Charles MacDonald, P-38 pilot, Pacific, 27 victories. In the European theater, Jack Ilfrey, P-38 pilot, 8 victories. Arthur Jeffrey, P-38 pilot, 6.5 victories. And these were just the aces. Hundreds of P-38 pilots were scoring victories against German and Japanese aircraft. The impossible. Design was systematically destroying the Luftwaffe and the Imperial Japanese Navy Air Service. The P-38's most famous mission proved what Kelly Johnson's design could do. April 18, 1943. American intelligence intercepted and decoded a Japanese message. Admiral Isoroku Yamamoto, architect of Pearl Harbor and commander of the Combined Fleet, would be flying to Bougainville Island for an inspection tour. The Americans decided to intercept and kill him. The problem, Yamamoto's route, was 435 miles from the nearest American airfield at Guadalcanal. Over open ocean, at wave-top height to avoid radar detection, with enough fuel to fight and return. No American fighter except the P-38 had the range. 16 P-38Gs from the 39th Fighter Squadron were selected. Led by Captain Thomas Lanfier and Lieutenant Rex Barber, they took off at 7:25 a.m. The flight required precise navigation over empty ocean with no landmarks. They flew at 50 feet altitude for over an hour to avoid detection. At exactly 9:34 a.m., they arrived at the intercept point. Yamamoto's transport, a Mitsubishi G4M Betty bomber, appeared exactly on schedule, escorted by 60 fighters. The P-38s climbed from sea level and attacked. The engagement lasted less than 5 minutes. Fier and Barber both fired on Yamamoto's transport. The Betty crashed into the jungle. Yamamoto was dead before the aircraft hit the ground. The P-38s returned to Guadalcanal. All but one made it back, shot down during the engagement, pilot rescued. The mission proved several things. The P-38's range was unmatched. No other Allied fighter could have reached the target. The P-38's reliability was excellent. Complex twin-engine aircraft, flying over open ocean for 4+ hours, at wave-top altitude, and all but one returned safely. Kelly Johnson's impossible design was, in fact, the most capable long-range fighter in the world. German intelligence officers monitoring Allied capabilities noted Operation Vengeance with concern. If the Americans could strike with that range and precision, nowhere was safe. By mid-1944, P-38 production was hitting full stride. 10,037 total P-38s built during the war. Peak production, over 500 per month in 1944. Multiple variants, P-38EL, each improving on the last combat effectiveness. By theater, European theater, 118 Plus, pressed German aircraft destroyed by P-38s. Countless ground targets, S-trains, trucks, tanks, installations. Escort missions from England to Berlin and back Pacific Theater. More Japanese aircraft destroyed by P-38s. After the P-38, Kelly Johnson continued designing aircraft at Lockheed. His achievements would define American aviation. P-80 Shooting Star, America's first operational jet fighter, F-104. Starfighter, Mach 2, Interceptor, U-2 spy plane. High-altitude reconnaissance, SR-71 Blackbird, Mach 3 Plus, strategic reconnaissance, still the fastest manned aircraft ever built. Founded Lockheed's Advanced Development Projects Division, better known as Skunk Works. Under his leadership, Skunk Works produced some of the most innovative aircraft in history. He retired in 1975 with more than 40 years of revolutionary designs behind him. But the P-38 Lightning was his first masterpiece. The design that proved a young engineer could solve impossible problems by ignoring what everyone knew was true. Today, approximately 10 flying P-38s remain in airworthy condition. They appear at air shows where crowds gather to see the distinctive twin-boom silhouette and hear the unique rumble of twin Allison engines. German veterans who see them remember. In a 1985 reunion of German and American fighter pilots, a former Luftwaffe pilot stood watching a P-38 fly past. An American veteran asked him, "What did you really think of the Lightning?" The German pilot was quiet for a moment, then said, "We called it der Gabelschwanz Teufel. At first, we laughed at the name, but after 1943, when we heard those twin engines coming from above, we knew the devil had found us. That sound meant you had perhaps 30 seconds to live. You could not climb to it. You could not outrun it. You could not hide from it. The fork-tailed devil was an appropriate name. It came from above like death itself." Kelly Johnson would later say about the P-38, "They told me it was impossible. I had to explain to them that impossibles just means nobody's figured out how to do it yet. The P-38 worked because we didn't try to build a conventional fighter with 2 engines. We built an entirely new kind of aircraft that happened to need 2 engines to meet the requirements." That's the difference between impossible and inevitable. The numbers tell Kelly Johnson's story. 10,037 P-38. Lightnings built, 1,800 German aircraft destroyed in air combat. European theater. Countless ground targets destroyed. Most successful long-range fighter of the early war years, proved twin-engine fighters could dominate when properly designed. June 18, 1940. Kelly Johnson looked at an impossible requirement and drew 2 circles instead of 1. By 1945, those two circles had become the fork-tailed devil. German pilots had stopped laughing long ago. The sky belonged to the lightning.